So, hello everyone. So today we are, this is a tutorial class, so we will start tutorial. Okay, so this mode we are starting after 2 years, okay. So quite excited that I'm in classroom actually. But if you are facing any difficulties, please let me know, okay. So in case my voice is not clear or what I'm writing is not clear, just let me know, okay. Okay, so we will start with problem number 6.1. Yeah, and what is talking about is qx is given, which is minus y square, qy is minus 2xy. So qx equal to minus y square and qy equal to minus xy. So these things are given. Okay, so and then given on the domain shown is figure 6.2. So these values are given. If you see at figure 6.2 is nothing but it says this is the domain where this is minus 1, 1. This is 1. Sorry, this is minus 1, minus 1. Then this is 1, minus 1. Here it is 1, 1. And here it is minus 1, 1. So on this it is defined. And verify the divergence theorem, it says.
So it is minus 2x.
Minus?
Qy is minus 2x.
Minus 2x, okay. Minus 2x. So verify divergence theorem. Verify divergence theorem. Everything all right, guys? Are you able to see everything?
Yes, sir.
Yes, sir.
Yeah, okay, great. Okay, so how to do it? So you know that the Q vector is given as qxi plus qyj, right? So, and we are going to work it out. So minus y square I plus rather minus 2xy j, right? So this is what a Q is, and divergence theorem we have to prove or verify. So basically what we want to do, a statement of a divergence theorem is divergence theorem is this is over omega, then divergence of Q d omega is equal to we have closed loop integral on boundary, and then this is nothing but Q dot n, right, and d gamma. So this is mathematics, basically mathematics problem, right? Divergence theorem is mathematics problem, and just we have to repeating basically something that we have learned in the engineering mathematics. Yeah. So is nothing. You are doing both the things. First you are going to find out this one, and then you will find out this one, and then you say both the values are same, and hence verify. You know, the verification means that just you have to do. So by doing that, you will understand how to apply the divergence theorem basically. Yeah? So what is the meaning of this closed loop integral, for example? Yeah. So what is the meaning? How we are applying? So let's start with this, the first term. So we have divergence of Q. So divergence of Q, we can start spelling it out. So this Q is equal to, we write del over del x I plus del over del y j, right? And then dot qxi plus qy j, right? So you have that. Then is equal to, we know that del qx over del x plus del qy over del y. So that is what that is, right? Is equal to, now we have those values qx minus y square. So we can write here equal to del minus qx is nothing but y square. So del x plus del minus 2xy over del y, right? Okay, so that is equal to, this will be 0 the first one, and second one will be minus 2x. So value will be equal to minus 2x simply. Yeah, so the value of divergence of Q is equal to minus 2x. Yeah. Any question, guys? Any questions? Yes, okay. Okay, once you have that, then you are going to integrate it over the whole domain. So this del Q d omega, this is the left hand side. So you write left hand side is equal to this, is equal to, and whole domain means over the whole area, that means, right? So actually that really means that minus 2x and over whole area. That's what the meaning is, over the whole area. Where area is this. This is the omega, right? This is the area, and this one is what the gamma is. Right? So loop, in loop you have to do, yeah? So that element, this is equal to nothing but minus 1 to 1, minus 1 to 1, minus 2x dx dy. So what that is, right? Okay, this is equal to, there is no y, so y can come out. So minus 1 to 1 dy. Yeah, so you can have also minus 2 here. This is constant that will come out. And then you have minus 1 to 1. And then x dx. Right? So that will be equal to minus 2 y minus 1 to 1. And then x square over 2. And then value 1 to minus 1. And that is equal to minus 2, and then we have 2 here. Sorry, 1.
31.
It should be 1 to minus 1. Okay. Yeah. Okay, so minus 2. Here we have 2, and here it will be 1 minus half minus half. Will be equal to 0. So it will be 0. Value will be 0. Okay, so now this value, you know that this is going to be 0. So we have to find out this one, whether it will get 0 or not. Right? Okay, so that's what we will do now. Any question, guys? Okay. Okay. Now, right hand side. Right hand side, and we will take this gamma q dot n. So q is this, and dot n. So n, we can say this is gamma 1, this is gamma 2, gamma 3, gamma 4. Right, and hence we will have this is N1, this is N2, this is N3, this is N4. So N is the unit vector which is at the boundary but projected outside, right? So that's what you have these four N's. So that means this is equal to, you will have to get Q dot N d gamma is equal to, the meaning of this is we are going to get gamma 1. So Q dot N1 dot d gamma over the gamma 1 plus gamma 2 Q dot N2 plus gamma 3 Q dot N3 d gamma plus gamma 4 Q dot N4 d gamma. There are four boundaries, and hence we have to look at all those four boundaries. So we start with one. Let's we call it number 1, I1, I2, I3, and I4. We can find out the values. So I1, I1 is this. So I1 means whatever the value is at the boundary, and we are integrating from here to here. And we have to get Q dot. So first we will do it. But first of all, N1 is equal to what? N1 is projected downwards. So that's a minus I. That's it, right? So N1 is equal to minus I. J term will be 0 because, minus J. So minus J, I term will be 0, right? So that means Q dot N at gamma 1 is equal to what? Now, if you see Q value, this is the Q, yeah, and here, what is varying? Here we have y equal to minus 1, right? Is fixed here. X equal to 1, y equal to 1, right? And then x equal to minus 1. So Q dot N 1, what is the meaning? Meaning is, first of all, you put the values of minus 1 here, because we are talking about this boundary. So here y is fixed. So anyway, we are going to have what? Or let us say, even if you are not convinced, looking at your face that I miss, no? Now I can see and say, okay, you're not convinced. So that's what we miss in the online classroom. So minus y square I dot, we are doing minus j, right? So I dot j, 0. So this term is gone. And then we have j dot j minus plus. So it becomes 2x simply, right? So we get 2x, 2xy, sorry, 2xy, right? So 2xy, and at gamma 1 is what? Gamma 1, basically on which, that really means that on that we have y equal to minus 1, and x varies from minus 1 to 1, right? So this is what the gamma 1 is, right? So basically y equal to minus 1, so we can write exactly, we can put it here. So minus 2, right? Minus 2x. At gamma 1 is like this. And then we have to integrate over gamma 1 what value? Minus 2x. And we have the del gamma. Del gamma means dx basically, because x varies from -1 to 1. So this basically is I1 will be equal to -1 to 1. Right? So this gives minus 2x square over 2. And we have 1 to -1 will be equal to 0 because this is the even number, even function. Yeah. So got it? We get that equal to 0. And similarly, we can have for others basically. Yeah. So we can have I2. Directly we can put -1. Here it will be -1 to 1, but we will have dy now. And then we have n2, right? So q dot n2, where you can put it here. N2 is equal to what? Just I. Right? So n2 equal to I. And I dot, here we get minus y square, right? This will be 0. So we get I dot q dot n is equal to minus y square. That's it. This term will be 0. So minus y square. So minus y square. And we have dy, because now the gamma 2 is vertical, goes like this. So what do we get? We get equal to minus, and then y cube over 3, 1 minus 1, and hence you get what? Minus 2 over 3. Right? It's fine. Okay, now I3 is equal to -1 to 1. And what is the value? N3, we can write N3 is equal to N3 will be equal to J. Okay, and then dot J here. So like earlier, this will go away. We have minus 2xy. Yeah, so we have minus 2xy, but y equal to 1. So we have minus 2x. So minus 2x and dx will be equal to 0, because you know x square will come here. So 0. Then I4 minus 1 to 1. And then we have to find out what is N4. N4 is equal to, this is backwards, so minus I. Okay, so Q dot N4. So Q is here, right? Q is here. N4, so minus I. So we get minus plus, and we get y square plus y square. This will be 0. So this you get y square. Okay, guys, there is something we missed. We have to see from where to where it's varying. So this varies from -1 to 1, x. Second one, so -1 to 1, -1 to 1, 1 to minus. Remember, so actually here we should have written 1 to -1. But anyway, it's 0, it says 0. You have to be careful. And here we have the y, which is from 1 to minus. So this is 1 to -1. Remember, you have to go like that. This is a loop. Yeah, so it has to go in a particular direction. Direction is important. Otherwise, it will not work. So y square, and then we have dy, right? Okay. So dy,
So minus dy.
it will be minus dy. That's correct. Yeah. So and then we have which is varying this way. Our ds is equal to minus. So we have to vary like ds is equal to minus yeah. Yeah. So anybody any question here, guys? Right. So you have to see that how the this is changing basically. So we have to go as per the S, right? So what is the relation between S and Y and dx? Accordingly, we have to do. Okay, so we have from here we get minus I. So minus I goes here, so that makes y square, and the ds equal to minus dy. So this is minus dy. Yeah. Okay, and that is nothing but equal to uh, same 2/3, right? You will get 2/3. So we can you can also write is equal to 1 minus 1 to 1, and then y squared dy. Yeah, and which is equal to 2/3. And what you have to do is total I, or right hand side is equal to I1 plus I2 plus I3 and I4, and which is equal to. So like accordingly we have to just to like in order to prove it, we did a few things that otherwise will be difficult, and hence all these things will be using basically. If you see the different kind of elements that we are going to use, we will have to integrate this way. So this example gives you basically where you have to be careful, and accordingly you have to work. Yeah. So here also you have to do minus dx basically. I3 also it will be minus dx. Like this. Any question? It's all right. Okay. Any question, guys? Those who are online?
No, sir.
Yeah. Okay. Otherwise, it was clear. Like you can see the board.
Yes, sir. It's clear.
Yeah. Okay. Great. Great. Okay. So let me erase it first before we move to other question. Okay. Okay, so number 2 we look at, we will just discuss how to solve this problem. Rest we should do it, but the problem is something like this. The domain is given, and the domain is something like this, and you have 2 0 minus 2 0, and you have 0 4. These are the points, right? Yeah. And this is n, which is given. This is the area, meaning that this is omega, and this is yours gamma, right? Okay, and then values are qx and qy. So qx 3x square y plus y cube, three x y square, probably x square y. Y is equal to 3x plus y cube. Okay. Okay, and then you have the curved boundary and verify the divergence theorem. It is same as earlier. You have to do it. And what we want to do in this case, how will you proceed? So if you have to integrate over this, what will you do? Of course, this is all mathematics. Even not, I should not be even teaching. Actually, believe me, like when I was doing the course, all those things were not taught. These were assumed that you know it. You know. But still in our course we do all those things so that you don't face any problem. You derive, you solve, so that you don't face any difficulty. But how to do it? You first find out qx equal to qxi plus qyj. So you have that, and first thing will be to left hand side, or this dot q d omega. You have to find out this left hand side is equal to this, is equal to now that really means del qx over del x is equal to 6xy, right? And this tells us del qy over del y over equal to 3y square, right? So basically this plus this nothing but divergence of q. So we get here 6xy plus 3y square. Yeah, you agree with me? So this is what you get. So this and over the whole area. So dA. Yeah. Now next thing is to how to do this integration. Right. So left hand side is equal to. How do you do? We have to find out all basic things, right? So you have this area, you can do like this. So what is the value of this? So this is y. First of all, you have to find out what is the equation of that. What is the equation of that? So
minus x square plus 4.
Okay. So minus plus 4, right? So you are saying y x equal to 4 minus x square, right?
Yes, sir.
Right. Okay, so the length of that, this is y. Y is equal to 4 minus x square, right? Y equal to, this will be nothing but 4 minus x square. Yeah, and multiplied by dx. So d area the area is nothing but is equal to y dx. This is the area, and now you can integrate over x now, right? So that means left hand side, but we can have this equal to first we have there are two things. Let's have this one first. So we write 6xy plus 3y square dA is nothing but y dx. Okay. Now we don't need two of them because the whole thing we wrote like this one, and okay, just a minute, guys. I think yeah.
Double इंटीग्रेशन से इजीली हो जाएगा, मतलब 6x² plus 2 और 3y square, that is 0 से लेके 4 minus x square में एक इंटीग्रेशन और दूसरे वाला minus 2 से 2 में.
Say again. So from 0 to
4 minus x square
हाँ
है ना, और उसको minus 2 से 2 में x के रिस्पेक्ट में इंटीग्रेट.
ठीक ठीक. So basically the same thing you have to do. But basically you have, there are two things. Within that also you are changing. So यहाँ पर ये देखना होगा. So we have which is moving from 0 to y, right? And where y is equal to 4 minus x square, and then this guy यहाँ पे ये जो है, this is dy, है ना? So basically we are going to write as dx. This one is dx, this is dy, so we write dx and dy, yeah, and okay. Then the x is, the y is varying, so this is y will be here and dx here. So y is varying from 0 to 4 minus x square, and then you have x which is varying from minus 2 to 2. So you do like this for minus x square. Okay. Okay. So whatever the value is, you can find out that. So easily it can be done. Right hand side, how will you do? For that you have to see what the value of n now. So you have there will be two n's. This is n1 and this is n2. Right? So that you have to relate, and for that you have to do some kind of mathematics you need. Yeah. So again, I assume you know all those things, but still we are doing here so that when you really apply these things on your problem, should not face any problem. So right hand side.
Sir, just a second. Sir, if I if we had put dy like y value of y there directly 4 minus x square, then we'll have taken only dx, right? Or y dx.
Only dy.
No, sir. I mean, if I had put the value of y there directly 4 minus x square and like change it into completely x.
No, you cannot do it. No, you cannot do it. This is because this is also varies for whole thing. No, it's not for the boundary you are doing. I mean, you are talking about the line integral.
Sir, only the integral part in LHS. Like while doing the integral, if I convert 6x into 4 minus x square plus 3 into 4 minus x square ka whole square, then what will we take outside? Y dx, like matlab 4 minus x square dx, or like dy I'll have to do.
Okay, so you are saying that you can put 6x and you multiply, you take y equal to 4 minus x square. That was it.
Yes, sir.
4 minus x square. That.
Yes, sir.
And then Mm,
Then I think we'll have to do y dx only that you were doing.
no, I don't think it is the same thing. This is because you see, when you say y equal to 4 minus x square, you are just referring to the boundary only. But this is not, you have to look at what individual value here is, so that varies with, you have to consider the whole domain, meaning that the whole area, not the boundary.
Okay, sir. Okay, sir.
Yeah?
Yes, sir.
In this case, it will be get the same answer if we do double integral as in dx into dx and then take from minus 2 to 2 and minus 2 to 2.
No, it will be different. So minus, what you are saying that from
Once we substitute y inside, if we do double dx, like first integrated by dx from minus 2 to 2, then again by dx from minus 2 to 2.
that will be something else, no? Y is not here. Y is varying from 0 to 4. It's not minus 2 to 2, no? So basically, see here, we are looking at, first of all, we have the value of divergence of Q, which varies everywhere. Then we have to multiply by dA, and dA is dx times dy. So everywhere, this value is different.
Sir, actually, that y is dy. When you wrote na, that should be dy.
Yeah, but that is boundary. This is boundary only, na? This curve is given by y equal to 4x minus y. See, just a boundary. It is not everywhere. It's just a boundary, na? Even this boundary is y equal to 0.
Sir, what I'm trying to say is the confusion is because you write there the y na. When you take the component, small component, you take the distance dy, and there in the diagram you take it y. That is why I think so. The whole confusion.
Okay, I got you.
It should be dy.
Yeah, so let's do something like this. Not to confuse, basically, what I will do, you will
So we
write.
can write y lambda or whatever
Just
it is.
we write it big Y. Yeah, so that makes it the boundary. Yeah, boundary equation is big Y, which is function of x square, and then here we will write is equal to y big Yx, right? Got it? So where this value is nothing but big Y from here to here, which is a function of x. This y is not the independent variable y. This is a function, different function. This big Y is not equal to y. Both are different. Big Y is this. Y is these values.
Yes. Yes. That's
Got it? So that's why. Yeah. Now clear now? Aditi?
Yes, sir. Yes, sir.
Okay. Yeah, so okay. Now right hand side, now we have to look at Q, we have to do Q dot, and then we have to do like that. So first we have to, of course, we have to find out what is the value of n, right? So what we know is n2 is very easy to know. N2 is equal to, which is downward. So you say minus j simply. N1 is something we have to find out. And that we do from the gradient. Yeah, so then we have to find out the M1, what you write is the gradient of this curve. For this one, it will be M1, which is the slope of this curve, will be d over dA, right? So right? This will be the gradient of this curve, right? It will change. and this is equal to del over del x, and big Y, x is 4 minus x square, right? Which is equal to minus 2x, right? Which slope is it? This is this slope. This is this slope. But n is perpendicular to this, like this one. Yeah, so we coordinate geometry, remember, like +2. So m1 times m2 equal to -1. So m2 is equal to minus 1 over m1 is equal to 1 over 2x. So the slope of that, right? So this m, or if it is a theta here, so tan theta is given by 1 over x. That really means, yeah. Got it. So if you write it here, that really means tan theta is equal to 1 over 2x. Yeah. Okay, if that is the case, then our n1 is equal to cos theta I plus sin theta j. Right? We will just work out from here only. So that is equal to what? What is cos theta? If tan theta is this, the cos theta will be x over root 1 over 4 x square I plus sin theta will be 1 over root 1 plus 4x square z. Okay? Yeah.
सर हमने इसको यूनिट वेक्टर कैसे अज्यूम कर लिया, मतलब क्योंकि मैग्नीट्यूड नहीं लिया है तो इसलिए या कोई और?
This is unit vector only. N1 is unit vector only. So that's why you can. It is very easy to do.
नहीं वो ठीक है, मतलब मैं कह रहा हूँ कि जो tan theta हमने लिया था उसके बाद जैसे हम लोग अगर इसको यूनिट वेक्टर अगर ये नहीं होता तो इसको हम r cos theta plus r sin theta इस तरीके से करते हैं। अगर हमने जैसे पहले ही r1 मान लिया है ऐसा assume करें।
Yeah. Yes, it's a unit vector. When you say unit vector means what?
Yes.
R equal to 1. It's a unit vector only, so we get like this. So n1 you get, and you can find out also if x equal to 0, let us say, वो कहाँ पर है? X equal to 0 यहाँ पे आएगा, and then what do you get? You get simply 1 j ऊपर की तरफ. So it's correct. You can also check. So at x equal to 0 it's upward. You can see that. And similarly, you can when x is positive, then what value you have? You have all the positive number. So it should be like this. So I mean, you have directed towards this one. Say correct. When x is negative, then this terms negative, this remains positive. So means the x term here negative ho jata. So I think it's okay. So n1 you got already. Now you have to do, next thing is how to find out the integral, right? Okay, and then for that you have q dot n, you can have that there, and then you have to integrate along the line. Again there is a issue here. So how will you do? Line जो है, you have along the line is given by y as a function of x, which is 4 minus x square. So basically, how do you do it? So if you have a curve, let us say, if you have a curve like ds here, right, and you have from here to here, you have this is dx dy, right? So ds is equal to dx square plus dy square. So this is root under of that. So ds is equal to, you have dx, and then you have root 1 plus dy over dx square, right? Which is equal to tan theta actually, right? Dx root 1 plus tan square theta, right? And tan square theta is this 1 over 4 square theta. So we can have is equal to dx 1 plus tan square theta. So 1 plus 4x square. Okay. So that makes it, you can have that 2x dx over root 1 plus 4x square. So this is ds. Okay, so ds has relation with that. Now next thing is
Said, don't you think it should be opposite, ulta, matlab 4x square plus 1 is above.
oh yeah. Right. That is correct. So you should have dx, and we will have 2x and root 1 plus 4x square. Yeah, you're right. Okay. So ds is there. So when you say you are going to have the q dot n, and we are going to integrate this gamma. D gamma is nothing but ds. Basically, we are talking about is the ds, right? Okay. So that is equal to q dot n. N we have already. Q we have already. So from here we get what is the qx? So yeah. So our so this is the value, right? Okay, Q, this one. N. So now it becomes complicated, as you see, right? So you will have this multiplied by that value, right? So I will just write q. You can do it. I will just write qx multiplied by cos theta, which is this guy. So qx 2x over root 1 plus 4x square, right? So you do like that, right? Okay, and then qx 2x over 1 plus 4x square. So we get like that, and then dot plus qy. Plus qy is multiplied by this value 1 over root 1 plus 4x square, right? So we have this value. What you see is the values which have y now. Which has y now. Now y you can replace with this y will be capital Y now, right? So this has, you can put y equal to yx. Why? Because now we're talking about the boundary. Now we're talking about xy at the boundary now. So you can have 3x square y. Instead of y, write 4 minus x square. Now you can do it. Okay. So you can do it here, and then you have ds, which will be dx divided by 2x. 1 plus 4x square over 2x dx. So you do like this now. So basically equal to, and this goes from where to where? We get x equal to 2 minus 2. Yeah. So we have to write 2 minus 2. Any question else? Okay.
2 to minus 2.
Okay. So
we have another N2 term, right? We have another term with N2, right?
then we have another term. So here you have to be careful. If you put value, I was thinking just I put all the values here, otherwise it will be confusing. So Qx will write 3x square, and instead of y you write 4 minus x square. So that's important. Plus y cube, so 4 minus x square cube. So you write like that. And then you have 2x over root 1 plus 4x square, and so on, right? So plus this 1 plus 4x square 2x dx. So long integration, so you have to do it. Now this one was this is the first one. So basically this is first one. Second one is this one, and in that case n2 is equal to minus j, right? So we already found out somewhere n2 RHS. Yeah. Okay, so dot n2, so minus j, so automatically we have here only qy term will be there, which will be minus 3x minus y cube, minus 3x minus y cube, and here we have varies dx, which is varies from minus 2 to 2. But what is the value of y there? Value of y is 0. So this is 0 basically. So we can find out this is nothing but 3. This value will be simply 0. Y x terms x square, and then it will be, so that will be 0 basically. I2 term will be 0. Main is I1 term. So basically that's how you have to do. Actually, yeah. So this is lengthy, but this is how you have to proceed. Yeah. Anywhere you have problem, always you have to find out what is relationship between S and the boundary. Always remember that. So basically, if you see that we have x in earlier problem, for example, let us say here, right? So our S is going like this. S is going like this, and our x is going like this, right? And what is the relation? Relation, it will be something like S plus x equal to 0, right? This is the relationship, sort of, right? Then this is 0, this is also 0. Then when S is minus 1, right? Then S is minus 1, like we have to read that way. So that means S equal to minus x. So ds equal to minus dx. So that way you have to relate. So accordingly, remember that. So instead of writing x and y, you can like in terms of x, just assume that the s is moving, and then accordingly we have to do. In this, s and x are aligned. We can say s equal to x, so everything ds equal to dx, and hence everything is good. Here also, like whenever you write you have some value, and then you have ds, and then you have to look at how the s value is changing, and accordingly you have to put the value. So those you have to accordingly you have to find out. So, any question, guys? Any question? Okay, so although we don't have much time, but still we will take one more problem, and very small problem, 6.3, and this is a very easy one. Okay, guys, just to clarify again, I think better to on this problem only. Let us say you have a function x square here, right? X square here, and which we have to integrate. Right? So we say like this and gamma. That we have to find out. And this is we are talking about this one. Let us say. So how will you do it? So gamma here will say that s, and s is changing like this. Means let us say this is minus x equal to -1, x equal to 2, x equal to 1, like this one, right? So finally we have x square. So we have to write everything in terms of s. You can also think that way. So you have s. What is the relationship between x and s? We can say s equal to -x, right? Or that means x equal to -s. So you can write this is equal to, in terms of s, if I'm writing, I will put x square minus s square, and this will be our ds, right? We will write ds, and then our s is going from, now in this case our s direction is, we are going from a -1 to 1 only. So this will be equal to minus s square, like this one. Same thing you can write in terms of x also. And how will we write? This equal to, now we will put x square will be x square. Now d gamma is nothing but ds we have. So we have dx equal to minus ds. So we write ds equal to minus dx. And then our x is going from 1 to -1. So we write 1 to -1. So basically, you get the same thing. Do you get the same thing? You get the same thing.
So that be x square ds.
What?
That be x square ds.
Yeah, okay. So this you have to look at finally. When you do it, it should be something like that. So if you have clear in your mind, then there will be no problem. Okay. Now just 6.3. And it says that,
7:15 will.
oh, acha. You can leave, man. Okay.
What is the 5 minute?
So 5 minutes is done. 5 minutes भी नहीं लगेगा ये small. So because this is today totally devoted to divergence and all that, So next time we'll look at something else. So it's very important because you will use it. So using divergence theorem, prove. So you have this, and then gamma. Okay, n d gamma is equal to 0. You have to prove that. Divergence theorem. You apply a divergence theorem. Okay, so as we discussed, there are two types, right? So either we write as divergence of some function, right? So let's say this is a function f. We typically write q here, right? This q is equal to, how do you write? Gamma. And then remember, what you have to do is, given this one, you replace this by n, that's it, and you are good. And you can also have, basically you can write like this, equal to n dot q. Nothing, just replace this with this, and gamma, the omega with the gamma, that's it, you are done.
That's del gamma, right? And del gamma.
Yeah. And you are fine. So this is one statement that we have to work on. The second statement is the, now this will be, this is for on divergence. Now it is gradient. Let us say this phi. Your phi is the scalar number, right? And or we can apply t, for example, right? T is a scalar number. So This one is equal to gamma, and then what will you do? You replace this by n, t. So that's what you have to do. Now, see here. This is equal to 0. You have to prove. Now, assume t equal to 1 in this case, right? Assume t equal to 1. That means what? This n d gamma is equal to this one, right? What is this?
0.
Gradient of 1.
0.
Right? So 0. Very simple. Yeah, this is very powerful statement, right? So you can do a lot of things. Any question, guys? Okay, if there is no question, thank you very much, guys. Okay, I will see you tomorrow at 10 o'clock. Okay, bye.
Thank you, sir.
Thank you, sir.